Now we begin to see why polar coordinate form for complex numbers is so important, because it transforms them into something that's complicated, into something you can almost do in your head, not joking, once you get reasonably comfortable with something called de Moivre's product theorem. And there will be quotient theorems and power theorems and so on. But for right now, I'm just talking about multiplying two complex numbers together. So first thing I want to do, let's walk through these steps right here. First thing I want to do is find out what is the modulus of w, this complex number. And remember what modulus is. It is the square root of the real part squared plus the imaginary part squared. So what is that? For w, this is the square root of negative 2 radical 3 squared plus negative 2 squared. And if you work through the math, you will eventually get to this point where it's equal to 4. Great, and I went ahead and already did this other one also. That's going to be 2. Now we can get into the more interesting parts. What are the arguments of each of these? Well, theta for w, and I want to keep these straight, theta for w is equal to the inverse tangent of the imaginary part divided by the real part. Okay, the inverse tangent of that. So if you look at w, remember what's the imaginary part? Okay, arctan right here. The imaginary part is negative 2, and the real part is negative 2 radical 3. Okay, so what this turns into is the inverse tangent of 1 over radical 3. Now you should know there's two places on the unit circle where tangent is equal to 1 over radical 3. One of them is pi over 6, and the other one is 7 pi over 6. So we have to decide, are we in quadrant 1 with pi over 6, or are we in quadrant 3 with 7 pi over 6? And if you look at this guy right here, this is a quadrant 3 angle. So I know the argument for this is going to be 7 pi over 6. And if you go through the same process for this other one, well, let's go through the process. I think this is a useful exercise. Theta of z equals the inverse tangent of imaginary part, which for z is negative radical 3, and the real part is 1. Well, that's easy. So where is this equal to, where is tangent equal to negative root 3? It's going to be two possibilities, 2 pi over 3 or 5 pi over 3. The question is, again, what quadrant are we in? So this guy right here, z, is in quadrant, think about it, real is positive, imaginary is negative, so that's to the right and down. That's quadrant 4. Okay, so we can cross out 2 pi over 3. We're looking at 5 pi over 3. We're through the preliminaries. Now, finding the modulus of eta, this guy right here, is easy. You just multiply 4 by 2, right? The modulus of w times the modulus of z will be the modulus of eta. So that part's easy. The argument is where it is also easy. It's just a lot of people can't believe it is this easy. All we do is we add up these numbers. Okay, so here, let's use magenta. For this guy right here, all I'm doing is I'm adding up 7 pi over 6 plus 5 pi over 3. Now, if you're quick with your fractions, you'll see this turns into, come on, be quick. Okay, 17 pi over 6. Right? I needed common denominators there. That's what was slowing me down. 17 pi over 6. Great. I put this in. The computer says I'm wrong. Why am I wrong? Well, keep in mind, I want the argument between 0 and 2 pi. We got to get used to finding coterminal angles that are on the ordinary unit circle. So I just need to find a coterminal angle. We've done this before. We subtract 2 pi. That gets us down to 5 pi over 6 instead of 17 pi over 6. Great. There's my theta. And now I can quickly write eta, which is the product of these two complex numbers, in polar form. I take the radius, or in other words, the magnitude, that's 8, and then its cosine of this angle I just found, 5 pi over 6, plus I times sine of 5 pi over 6. And if you're wondering where I got that, that's right here, remember? That's the polar form. You'll need to get used to that, but for the time being, I'm going to keep writing these down to remind you. And now the last thing to do is just convert that into rectangular form. Okay, so One last step here. Let's go back to orange. I want to convert this to rectangular form. So all I do is I say, no problem, here's eta equals 8 times, what's the cosine of 5 pi over 6? 5 pi over 6. That's going to be negative radical 3 over 2. And the sine of 5 pi over 6 is just 1/2. Okay, so that's my rectangular form. Let's simplify it a little bit. This becomes negative 4 root 3 plus 4i. Okay, that is the rectangular result of multiplying these two complex numbers.